Hello everyone, Aaron here and welcome back to Leetcode. Today we're doing the rectangle area problem. Given the coordinates of two rectilinear rectangles in a 2D plane, return the total area covered by the two rectangles. The first rectangle is defined by its bottom left corner and its top right corner. The second rectangle is defined by its bottom left corner, top right corner, so AX1, AY1, AX2, AY. Okay, so it's XY, 1, 2, AB. That's our setup. The area covered by the two rectangles is this area. So that's -3 to 3. So that's a 6x4 area. And this one is covering a 9x3 area. So that's 24, but I'll do it over here. In the example, we have, what did I say it was? I said it was a 6x4 and a 9x3. That's 24, that's 27. If we were to just naively add those up, that would give us 51. But the problem is there's an area that is covered by both. Then it goes from 0, 0 to 3, 2. So we have a 3x2 area, which is 6. And if I subtract that, I get 45. And the idea is we counted this area twice. I did all of this area and all of this area, and this pink area was used twice, so we have to subtract it to make sure we only count it once. So, it seems to me that the challenge here is calculating the overlap area. So, self.compute area AX1, AY1, AX2, AY2, A area. Whoops. Whoa, what happened there? Why can't I undo that? I'm back. My computer went haywire. I think my keyboard started sending signals. So, what was I saying? Areas. A area is equal to self.compute area AX1, AY1, AX2, AY2. B area is self.compute area BX1, BX2, BY1, BX2, BY2. And then it's going to be the overlap is self.compute overlap. This wants all of them. AX1, AY1, AX2, AY2, BX1, BY1, BX2, BY2. And overlap area is self.compute area of the overlap. Return A area plus B area minus overlap area. So now we're left just doing these helper functions. Now the A area and B area, that self.compute area. Oops, the compute area self x1, y1, x2, y2. This is just going to be x2, in fact it's going to be abs of x2 minus x1 plus the absolute value of y2 minus y1. Whoops, not plus, times. I'm doing an area. So if we were to do x2 minus x1, 3 minus minus 3 is 6, and 4 minus 0 is... Oh, in fact, I don't need the abs because I know they are in order. So that is the area. And then finally it's def compute overlap self ax1, ay1, ax2, ay2, bx1, by1, bx2, by2. That's an awful number of parameters. I really should tidy those up into a proper object, but I'm not going to. So basically the idea is we want to, on the x coordinates, get all 4 x coordinates, put them in order and take the middle two. Same with the y coordinates. Those are our central region, basically. X's is ax1, ax2, bx1, bx2, x's dot sort, y's is equal to ay1, ay2, by1, by2, y's dot sort, return x is 1, y is 1, x is 2, y is 2. That will give us this little area. We sort the y's that way, we sort the x's that way. We end up with this nice little quadruple. However, I don't think this is correct. And the reason I don't think this is correct is because this assumes there is an overlap. And then if I put them in order, that's the overlap that I'm finding. So let's imagine this red box here. It was actually from 1 to 2 on the y-axis. So in this case, it works fine again. But if instead the y box went from -1 to 0, taking the middle two would be 0, 0. Actually, that works. Okay, let's say the red box went from -2 to -1 on the y-axis. And this one goes from 0 to 4. We would take the middle two, which is -1 and 0, and say, oh, it's got height 1. But in fact, it has height nothing. There is no height. So what we need to do is basically do a little check. If ax1, in fact, if ax2 is less than bx1, or ax1 is less than bx2. So if ax1, if ax2, this thing here, is less than bx1, this thing over here, that means the red is entirely shifted to the, what way is that, right of the purple box, or the purple is entirely shifted to the left of the red box, then there's no overlap. Similarly, we need to do something for the y. If ay2 is less than by1, or ay1 is less than by2, return 0, 0, 0, 0. In fact, there's more cases than this, isn't there? So this is the case. If ax1 is less than bx2, no, that's not the case I want at all. I want to do bx2 is less than ax1. by2 is less than ay1. So if the purple box is too far to the left or too far to the right, and then if the purple box is all the way too low or all the way too high, both of those are 0 cases. Now I think that's what this second example might be doing. -2, -2 to 2, 2. Oh no, that's doing just a perfect overlap between them. That's fine. So let's see if this works. It did not work. Why did that not work? I got a 66. Hang on. Print overlap for me. I said from 0. I should have said from 0, 0. I think I was missing some parentheses there. Now I'm saying from 0, -1. Hang on, I need to see what the x's and y's are, because that's surprising to me. -3, 0, 3, 9. So the x's should be, hang on, 0, -1. Oh no, 0. Sorry, yeah. -3, 0, 3, 9. Yes, that's expected. So I should be doing 0 to 3. But here, and the y's are -1. It should be -1, 0, 2, 4. Y1, y2, b1. I made a mistake up here. Yeah, I've made a mistake up there. This is why if you have so many parameters, it's easy to make a mistake, particularly when they're all labeled the same. So now I'm saying from 0, no, this is still wrong. No, that was correct. A x1, a y1, a x2, a y2, b x1, b y1, b x2, b y2. That's correct. So hang on, why is y a y1, a y2, b y typos? Oh my goodness. There we go. Once we've got the typos sorted, suddenly it gets a bit easier. Right. That seems to work. Let's use all the example test cases. Perfect. Now let's do another one. Let's say I want to go from -3, 0 up to -1, 3. And then I want to go from 0, -1 over to 9, 2. I don't mind that, but we should have not had to double count the region in the middle. Excellent, we are avoiding that. So those numbers I put in, it may not be easy to tell, but I was specifically making sure that I was avoiding any overlap between the two rectangles. Really nice to have something I could just scribble on right now. Anyway, let's submit it. See how we do. Excellent. Rectangle overlap. A nice wee problem. What's this one's difficulty? Medium. Oh, that's a surprise. I guess the trick here is how to find these, but once you realize the trick is you just want the middle two, that's not so bad. You just got to handle these edge cases first. So I think on the scale of mediums, this is on the easier end. Sometimes mediums can be absolutely beastly, but this one was just recognizing you have to not double count the middle and how to compute that middle region. Anyway, that's it from me today. Do let me know down in the comments how you got on, if you gave this one a go, what approach you took. Is there, you could segment these much more. You could compute the purple region without this, or You could cut it up to where they meet and start slicing and dicing into, say, 1, 2, 3, 4, 5 rectangles, or even further, up to 7 rectangles. 1, 2, 3, 4, 5, 6, 7 rectangles. So do let me know how you got on. It'll be very interesting to hear all the different approaches. Anyway, do remember to like, comment, subscribe, all of that good stuff, and I will see you next time. Bye.